Hi, I'm Sven. One more thing about the relationship of machine learning and optimization. We've had an episode about that before, but there is one particular technique in machine learning that matches with optimization in an elegant but unexpected way. So today, let's talk about linear regression. Welcome to Optano. Do you know the trend lines you can generate with your spreadsheet software to gather insights on system behavior or future developments? A common example is the prediction of house prices based on size, renovation state and more. But it works for every topic where we want to predict a specific value based on some observations we can make, called parameters or features. The idea behind linear regression is to find a predictor that predicts the value we're interested in, house price, carbon emissions, waste generation, whatever, based on the inputs that we already know. The techniques to do this were already there long before machine learning was put in use on a large scale. Based on history data, we find a predictor that makes its prediction as accurately as possible, which means the estimation error is as small as possible. Mathematically, this is a polynomial of the input parameters that generates the interesting output parameter. And the machine learning process is all about finding the best coefficients of this polynomial, which means that the result is a linear equation, which is why it is called linear regression to begin with. Now, let's forget about house prices and think about some large system we can control. We can apply linear regression to find predictors for, let's say, energy consumption. And each predictor is a linear equation. Now, this calls for linear programming, ain't it? Let's take the polynomials of the predictors and add some constraints to model which output values we want to achieve. Now, treat the inputs as variables instead and not as given facts. Voila! With linear programming, we can now calculate the best values we should use as inputs in order to achieve the desired output behavior. Which means we have now a really good proposal on how to efficiently run our complex system. If I think about this, this might be a very interesting approach to keep energy consumption at bay for some heavy industries. Linear regression is a workhorse of machine learning, and while it's typically used to predict outcomes for some observed inputs, we can turn this around. Combined with linear programming, we can calculate the optimal inputs to achieve a desired output and apply this to energy-heavy complex control systems. I really love it when my favorite topics meet. See you next time and stay safe!